I'm going to be talking about antiderivatives. Antiderivatives are the opposite of derivatives. Um, how you're supposed to do them, well, basically, you go the opposite route. So, like in derivatives, when you subtract 1 from the exponent, like usually, in this, you would add 1 back to the exponent. And then you'd like set up a sort of like an equation. So if it was like x squared, let's just say, then that would turn into x, and then you'd add 1, so then 2 plus 1, that would turn into a 3, and then you set up a sort of an equation like 3 times what value would get me 1 in as the coefficient. So then it'd end up being the reciprocal. It'd be a third. So that would be basically it'd end up equaling a third x cubed for x squared's antiderivative. There's also a formula for it, but I won't get into that. Just note that the square root of a function is like to the exponent of 1/2, and if there's a variable in the denominator, you do the same process. You bring it up to the numerator by making the exponent negative, and then you add 1 to that, and then do the same process. Now let me do an example. So let's just say you were given this. So the square root of x minus the square root of x cubed plus 5x cubed plus pi dx. So I need to take its antiderivative. S dx. So for this one, this is x to the 1/2, like I mentioned previously. So how do I solve this? I add 1 to it. This will turn into a 2. So that becomes into 3 halves. And then I set up a sort of an equation. So 3 halves times what gets me? 1. So then it end up being its reciprocal. So now we have 2/3 x to the 3 halves. And I suppose you could write like the square root of x cubed, but I mean, you don't need to. And then for the next term, I'll just do that here. It's x and 3 halves, And so for this, I would add 1 to it over 2. So then that would turn into a 2. So that would turn into 5 halves. And then I do the same sort of process. I do an equation of sorts with it. So it would be 5 halves times what would get me 1 minus. So I'd end up multiplying by its, or having its reciprocal. My, it's supposed to be a 5. So this would end up being 2 fifths x to the 5 halves. And then for the next term, there's a 3 in the denominator, so then that would turn into x to the negative 3, because I'll bring it up to the numerator, and then I'd add 1, which would make it negative 2, and then I'd bring that in the front, so then that'd be negative 2x to the negative 2 of what I need to do an equation. So negative 2 times what would get me 1. So that'd be negative 1. Let me do this here. So I'd 5 times negative 1 half x yeah. So for the last term, there's oh, okay. Also note it would be 5x would equal negative negative 2x would equal 5. You could do it this way instead of doing what I did. Anyway, that's besides the point. If the next term is a pi, and since that's a constant, its derivative, or its 0, antiderivative would be pi to the x, because then, and that's because, yeah. So that's how you'd solve this. Oh yeah, and make sure you always have plus c at the end, and I think so. This whole thing is a solution for this question. 0 plus 1. So yeah. So let me erase this now. So that's basically how you solve antiderivatives, and make sure you go over the other concepts of the test. And before I go, note that, for example, like cosine of x, antiderivative is sine of x, and the derivative, therefore, of sine of x would be cosine of x. You could check yourself that way. But, and then sine of x, is antiderivative is negative cosine of x. And tangent of x is antiderivative is secant the other way around. Secant squared of x is antiderivative is tangent of x, and negative cosecant squared's derivative is cotangent of x, and it could the negative sign could vary. It could be here, but then not here. Like negative sign of x is the antiderivative because it's cosine of x. And secant x and tangent of x's antiderivative is secant of x, and cosecant of x, negative, and cotangent of x's antiderivative is cosecant of x. So yeah, just keep these in mind, perhaps. And put an x, the s in the front, and dx at the end, perhaps whenever you do this, like in the first column. Like that's how it would be given to you, and then you would know to do its antiderivative. So that's it. I suppose. So let me erase this. So that's all you need to know.